I watched a senior engineer with 8 years of experience build really good code, good patterns, solid test coverage, looked great on paper. Then I watched it crash and burn in production at 1/10 of the scale of a legacy code it was supposed to replace. I was the mid-level on the team who saw the problems early, tried to raise concerns 3 different times, and nobody listened. This is how I learned that beautiful code is completely worthless. It's 2018. I'm working with a mid-sized e-commerce company. They do about $50 million in annual repeating revenue. 7 backend engineers, 3 maintaining the legacy PHP system, 4 of us building the future. I was on the future team. Well, management brings in Steven, 8 years of experience, recently gave a talk called Why Code Quality is Your Competitive Advantage. I'm only 2 years in. I'm excited to learn from someone like this. First team meeting, Steven's on the whiteboard for hours, showing architecture repository patterns, event sourcing, and everything that you need. All the clean code book stuff. And I'm thinking, this is really impressive. This is how you're supposed to build systems. But there's something in how he talks about it. This confidence that borders on dismissiveness. He waves his hand at the legacy system saying, this is exactly why we need this migration to happen now. Clean code is what matters. I'm cautiously optimistic. The patterns make sense, but something feels off about ignoring everything else. What I didn't realize was that Steven was optimizing for the wrong backend pillar, and I was about to watch it play out in slow motion. Steven's first PR comes in. The code is clean. It's nicely structured. It has proper dependency injection. It follows everything you'd want it to follow. He had a few comments, mostly positive, 2 comments that were talking about caching, but he replied and said, we don't want too much premature optimization. Then Steven assigns us, me and a couple other people, to study the legacy PHP system, understanding why we're migrating. I open it. The legacy system is really messy. One of the files has 4,847 lines. It has no classes, SQL concatenation, magic numbers, pure spaghetti. Steven also looked at it, and in stand-up, he mentioned that it was worse than he thought. But I'm curious because it's currently running properly. Of course, it could be better, code quality, but it worked. So I dug deeper. And I started to find things buried in the configuration file, scattered through the deployment scripts, the whole hidden infrastructure of this legacy application. It has a 3-tier caching, and the cache rate is 91%. It also has 47 database indexes on the orders table alone, partitioning by month, 3 read replicates, and then I found custom metrics for clients, 240 to be exact, tracked across every step of checkout, error rates by payment method, latency percentiles, and real-time dashboards. It had everything you need in case a disaster happened. So I went back and looked at the Black Friday of 2017 data because it was the year before, and it had 85,000 concurrent users, 77,000 orders, 246 milliseconds on average with an uptime of 99.4%. I'm staring at these numbers thinking wow, this is really impressive. So I grab coffee with Mike. He's the legacy team lead, 15 years at the company. I show him the numbers. I remember telling him, Mike, the code's a mess, but these numbers are really good. How'd you do it? I still remember today because I felt it felt funny because I just remember him leaning back, taking a sip of his coffee and saying, code quality is just one dimension, Eric. Infrastructure, database design, observability, those matter too. Maybe more when you're under load than you think. And that still sticks with me today. Code's just one dimension. We give so much credit and so much effort toward code, but it's only one dimension. It's only one pillar of building software. So I bring it up in our planning. I said hey, Steven, I looked at the Black Friday metrics and they handled 85,000 concurrent users. Should we be looking at more caching and observability to kind of match what they were doing in production today? And I remember Steven barely even looking at me. That's just compensating for bad code, Eric. Clean architecture doesn't need all that infrastructure. Trust me. And I'm thinking, well, the data doesn't lie, right? But he has 8 years. I have 2 years. Maybe I'm missing something. This was the first time I raised a concern and I was shut down almost instantly. Over the next 2 months, we start building out Steven's vision. The code is very clean. I'm going to give Steven all the credit for that. It's clean. It has clean structures. The patterns are great. Everything's testable. It's very satisfying. But that question keeps nagging me. Will it scale? While Steven's perfecting the code, infrastructure is delegated to a DevOps engineer who's never scaled before. That DevOps engineer really knew what they were doing, but not in the standpoint of how to scale users. And on top of it, we barely used caching. In staging for this new system, caching only hit 23%. The legacy app had 91%. And observability, we had basic logs, but no custom metrics metrics, no query visibility. So I do something I've never done before. I start documenting everything. I create a document called like production readiness concerns or something, whatever I was thinking at the time. And I list them out. As at the cache hit rate, we have 23%, legacy system was 91. We have no query monitoring. The production one has a ton of query monitoring. We have no sustained load testing. We're missing composite indexes. I spent a little bit of time adding links to all the legacy metrics, and I added some suggestions, and I sent it over to Steven. His response was what you'd expect. Again, thanks for thinking about this, Eric, but we don't want to over-engineer the first MVP. We'll address issues if they show up in beta. But beta was October. Black Friday's November. So let's go ahead and fast forward it to the week before beta. We load test 1,000 current users. It works. No issues at all. And you know why? Because we're testing with 1,000 users, not the 85,000 users that was on Black Friday last year. And I bring this up again, that we need to test with more people. Steven looks at me and the rest of the team. Eric, I appreciate you being thorough, but we can't let perfection be the enemy of good enough, which is something I believe in. I always talk about good enough, but good enough means good enough for what you're trying to do, not just shipping code. But other engineers nod. It sounds reasonable when someone says it, whether they're right in the context or not. Everyone's, is confident, so I stay quiet. 2 times now. 2 times I've raised concerns. 2 times I was told not to worry. I didn't know it yet, but I was running out of chances. Fast forward to the beta launch day. We flipped the feature flag. New checkout enabled for 5% of the users. I'm at my desk with everybody else watching. We only have 3 metrics. That's all we have. CPU, 15%, looks good. Memory, 38%. Okay. Error rate, 0%. It's exactly what we want. But I still can't shake the mindset of the 244 custom metrics that the other system had that we're not looking at. We're looking at connection pool utilization? No. The cache hit rate? No. The query performances? No. After lunch, the first order's complete. It was fast, 142 milliseconds. But 30 minutes later, we got a customer support message in a Slack channel of hashtag incidents. Getting reports of slow checkout. Is something wrong? I remember me and Steven looking at the dashboard. We look at the numbers. He types in Slack, probably just perception. Numbers look fine, but then it happens again and again. And then we finally get the dreaded database connection error, connection pool exhausted. I refresh the dashboard. Error rate is climbing. Support tickets start coming in. And here's what we couldn't see, all the issues, because we weren't adding in the metrics. Behind the dashboard showing the CPU and the memory, we couldn't see the queries or the database connections. Our beautiful, beautiful repository pattern was lazy loading everything. We had to roll back our modern application to the legacy app. The rollback takes 47 minutes. At the time, it was the longest 47 minutes of my career. And here's the thing. It wasn't even Black Friday. It wasn't even the big day of the 85,000 concurrent users that I had in the back of my mind. This was just beta. We probably had a little over 1,000. We load tested at probably the maximum that we thought would happen on that day, but we were so close to crashing, and that's not even close to the 85,000 we had on Black Friday the year before. So I take a breath. I think there are 4 pillars to a production system. We nailed 1, code quality. Didn't really nail it all that well. We ignored 3. We go over each pillar. There's the first pillar, which is code quality. Yes, our code was clean, beautiful even. And that does matter. Clean code is easier to maintain, is easier to onboard to, easier to reason about. Those are real benefits of having clean code. But clean code doesn't automatically mean scalable code. It doesn't automatically mean you're building the right thing for the product. Let me show you what I mean. Our repository pattern was textbook example of a good design. Had single responsibility, dependency injection, it was testable, everything the clean code book tells you to do. Here's what it looked like conceptually. We had a product repository that handles products. We had a category repository that handled categories. We had a user repository, which you probably can guess what it did. It handled users. They were separated, they were clean, they were easy to test. But this is what happened. We called the get product details for a single product page. First, we fetch the product. 1 query, makes sense. Then the product object has a category property. We access it, we lazy load the second query. That category has a parent category. We access it, third query. The product has reviews. Now we can say it has 10 reviews for this example, but if it had 10 reviews, that's 10 more queries. We were falling into the N+1 trap. In the legacy system, that ugly 4,847 line file had 2 queries. 1 query with a massive join that gets the product category and the parent category, and 1 query that batch fetched all the reviews for the user. Is it ugly? Absolutely. Can you maintain it easily? Probably not. But can you see every query? Does it have the metrics to get you by? Yes. Our clean abstractions made the expensive operations invisible. And here's the thing that really bothers me. We never would have caught this in code review. Look at this from like a code review process. Is the code modular? Yes. Check. Is it testable? Yes. Does it follow solid principles? Yes. Approved? Ship it. No one was looking at the queries because the queries were hidden behind. Nobody asked how many queries does this generate because you can't see it. The abstraction hid it from us. Steven was working on the queries. We just called them through our repository. And if you ask Eric, why didn't you catch it when you were testing? Well, that's because we were creating mocks. We genuinely never tested the one thing that matters, and that's behavior under real production load. And it's not just queries, it's the memory too. Now, pillar 2 is the infrastructure and scaling strategy. This is where we really failed as a team. And I own some of this too. I saw the infrastructure gap and I didn't push hard enough. The legacy system had 3-tier caching: application, Redis, and CDN. Had database partitioning by month. 3 read replicas, custom connection pooling. We built our code first and delegated infrastructure to a DevOps engineer who's never scaled an e-commerce store before. That should have been a red flag in itself, but we just kept moving forward. We had minimal caching, 23%, one database instance. Steven said something in the planning that I can't get out of my mind. And it's that clean architecture won't need all that infrastructure. I said that earlier in this story, and that's just simply not how it works. Infrastructure doesn't compensate for bad code. Infrastructure is like the foundation for the code. Under load, infrastructure beats whatever you're trying to do in your architecture almost every single time. Because when you have 85,000 concurrent users, even the most perfect optimized query takes time. Even if you get the query down to 5 milliseconds, multiply that by 85,000, you need more infrastructure. There's a reason all these giant tech companies have crazy infrastructures. You need caching to handle repeated requests. You need connection pooling to manage database connections. You need read replicas to distribute load. This isn't optional. This is literally the baseline. So here's the question you need to ask yourself every time you build a system. How and when will you need to scale to 10 times the traffic? And if it's kind of soon, can your database handle it? Can your cache handle it? Can your network handle it? If you can't answer those questions, your system is not ready to be scaled. And if your system's not ready to be scaled, and because you don't have the users, that's fine. But if you have the users, you need to figure it out. Now, pillar 3 is observability. This one hurts the most because we could have caught this. The legacy system has 247 metrics. Like I mentioned earlier, we built 3. When things started going wrong, we were completely blind. We could see error rates climbing, but we couldn't see why. We couldn't see which queries were slow, which endpoints were struggling, where the bottlenecks were. Simply put, you can't fix what you can't see. Observability isn't just logging. Logs tell you what happened. That's valuable, but metrics tell you why. Here's what we should have implemented from day one. We should have implemented some type of query performance metrics. We should have implemented some resource utilization metrics. We should have implemented, some business metrics over how everything's working. The legacy system had all of this. That's how Mike and his team knew they could handle Black Friday. They watched the metrics climb and they knew exactly where to put their ceilings to match where the metrics could go. We didn't know our ceiling until we hit our head on it. And here's the thing. It's not about building a monitoring system from scratch. You can use tools. There's tools that exist. Datadog, New Relic, it doesn't matter. Just pick one. Instrument your code. Expose the metrics that matter. Observability is the difference between responding to a fire and preventing one. And as a backend engineer, you always want to prevent it. Now, pillar 4 is the operational culture. This is the part that nobody teaches you. And it's by far one of the most important ones. Culture. The culture you're in kills more systems than bad code ever will. And here's what I mean. I raised concerns 3 times. 1 in planning, when I showed the Black Friday metrics and asked about caching. 2, in the code review, I documented production readiness concerns. 3, before beta, I questioned the load test scope. Each time, I was told the same thing. Don't over-engineer. We'll fix issues when they come up. They're real on trust me bro moments. Those kind of messages shut down discussions. Because Steven had 8 years of experience and I only had 2, his confidence was treated as expertise. But confidence and expertise aren't the same thing. Steven was confident in clean code because he has seen it work, but he's never scaled an application to 85,000 concurrent users. And neither have I. Neither had anyone on our modern team. The only person was Mike, and we weren't even talking to Mike. We had a culture that rewarded elegance over resilience, that treated production readiness as a nice to have instead of a requirement. And that culture always comes from the top. When leadership rewards beautiful demos over boring reliability, you get what we got. Real engineering isn't just about writing code. It's about designing systems that can survive contact with reality. If you've ever been on a team where clean code got prioritized over operational reality, let me know in the comments. And if you want me to break down, each one of those pillars a little bit more, let me know. I'll make videos on them. Thanks for watching, and I'll see you in the next video.